Hi there and welcome to the second lesson on sampling. And in this video, we're going to try and understand the different sampling techniques that we use. And we're going to try and do some sort of critique on each of those sampling techniques to see what advantages and disadvantages they have. Before I do that, though, if you remember back to the end of the last lesson, I left you with a check-in question, which said that a school had 1,200 pupils and the school wanted to change its uniform and decided to ask the opinion of 100 of its pupils. And I asked you to come up with at least 3 different ways that the school could select a sample size of 100 pupils from its population. I've managed to come up with a few suggestions here. So the first suggestion is to assign each pupil in the school a number, and then we could randomly select 100 pupils from the 1,200. There are many ways of doing this, and one of those is to use the random number generator that's on a calculator. And as we've used it many times, it is randomly done. So that is called a random sample. Another way of selecting 100 pupils would be, again, to assign each pupil a number. And this time, select every 12th pupil on the list. The reason for selecting every 12th pupil on the list is because there are 1,200 pupils in the school and we want to take a sample of 100, and if I divide 1,200 by 100, it equals 12. So we can select every 12th person in the list. To do that, the first person we choose must be done randomly to get a starting position, and this is called systematic sampling. Another way we could select 100 pupils is to take a random sample from each year group that is representative of each year group. So if, say, for example, year 11 had the biggest cohort, we would want to select more pupils of our 100 to be selected from year 11. And that would give us a representative, fair representation of each year group. And that is called a stratified sample. Or we could even just stand at the school gates and get the opinion of the first 100 pupils to arrive. So to get the first 100 pupils to give their opinion on whether they should change the school uniform or not. And because we're stood at the school gates and we're just coming across the first 100 pupils we see, it's an opportunity. So we call that opportunity sampling. There may be other methods that you've come up with. Of these methods here, we are going to be focusing on the following. We're going to be focusing on random sampling, systematic sampling, and opportunity sampling. The stratified sampling is not on the specification for WJEC. So you may want to pause the video at certain points to make some key notes, so it helps you with answering some questions later on. So the key sampling techniques then that we need to consider are this simple random sampling, where each member of the population has got an equal probability of chance of being selected as being part of the sample. Systematic sampling, where we pick a random starting point and then a fixed sampling interval. And we find the sampling interval by dividing the population size by the desired sample size. So if I go back to this one here, where I said every 12th person, the population size was 1,200, and we wanted a sample size of 100. And that helps us calculate that. And opportunity sampling is the third type of sampling we need to be considering. And this involves taking people from the population that are actually available at that time and are willing to take part in the survey. So when we select our technique for sampling, okay, we need to make sure that our ideal sample will be a large enough sample to represent the population. What can happen with a small sample is it can produce some strange results and might not be representative of the whole population. So the sample must represent the population as well. And the most important thing really as well is that the sample needs to be an unbiased sample. So for example, the time of day the sample is taken can be really important. So if you was in a supermarket and you wanted to get some feedback from the consumers, and you did the sample on a Wednesday between 9 and 12, then we would expect that most people would either be in school, would be working. So the sample there may contain people who are retired, so the older generation of people. So it might be a biased sample towards the older generation, okay? And where the sample is also taken is really important. So when we critique our sampling procedures, there are advantages and disadvantages for each. So if we're going to take a simple random sample, then the advantages of doing this is that it's the least biased of all the sampling techniques, in that each person has got an equal chance of being selected from the population. It's quite easy to perform. So for example, on using a random number generator on a calculator, or using a function on a spreadsheet, for example. And the sample is likely to be highly representative of the population as well. The disadvantages of a simple random sample is that it could be time consuming and quite tedious to perform. And sometimes it may lead to a poor representation of the overall population. So the random sample may contain more females than males, for example. So our systematic sampling then, what are the advantages of that? Well, it's more straightforward to do compared to simple random sampling. And the sample is quite easy to select as well from a population. The disadvantages of the systematic sampling approach is it's less random than simple random sampling. And finally, the opportunity sampling then. So it's taken our opportunity to find a random sample, okay? And so it's quite easy to do. You could just position yourself at a certain time in a certain place. So it's quite easy to take. And it's taken from part of the population that's closest to hand to you. The disadvantages of opportunity sampling is it can be highly unrepresentative of the population, as it's not randomly selected. Okay, so let's have a look at this example then, all right, and put it into a context. So in this example then, a researcher is collecting data about the amount of television watched by 20 different 5-year-olds on a Saturday. The results in hours are shown in this list here. Taking an opportunity sample of the first 5 numbers in the list, so the opportunity is always the first ones you come across, so there's your first 5 numbers in the list. We're being asked to calculate the mean number of hours watched on a Saturday. So to calculate the mean, we just simply add up the 5 data values and we divide it by 5. Quite straightforward to find the mean, giving us a solution here of 5.2. Okay, part B then is more about the systematic approach of getting a sample. So we are going to be taking 5 data values. So we need to work out the sampling interval. So we know that we're going to be taking a sample of 5 from the population of 20 that was originally researched. So in this case then, the sampling interval will be the population size here, which is 20, divided by the 5 sample size, which is 4. So that means that we are going to be selecting every 4th item on the list, okay, every 4th person. Okay, but with a sample, a systematic sample, we need a starting position, which must be done at random. So that's part 1 here. So part 2 is asking us, a random number was chosen in the sampling interval and it was 3. So we need here now to find the 3rd person. So if I find here, there's your 3rd person. So we start with the person here who's watched the TV for 2 hours, and we must go to every 4th one. So from there, 1, 2, 3, 4. There's my next item from the list I choose, and then again another 4, and then keep doing that until you've selected 5. So it's equal gaps And the final one is this one here, it's 7. So we're able to select those 5 values using a systematic approach, sample approach. Okay, so part 3 then is asking us now to, from that list, work out the mean number of hours watched. So again, it's just simple maths, adding those together and divided by 5. So quite straightforward to perform that. In this case, it's 20 divided by 5 is 4. So part C is asking us to state and give reasons which sampling method is more likely to give the reliable results. So always a systematic sample will provide better results than an opportunity sample. Okay, so it's better. All right. It's more random than an opportunity sample and uses numbers throughout the distribution, not just the first 5. So, as I said, it'll be a bit more random and maybe more representational. Okay, what I would like you to do now is I'd like you to have a go at the main task, which is these 6 questions here. So you will need in a moment to pause the video and have a go at those, and I will post you the solutions to those. And then press play to come to the check-in question. Okay, so at this stage now, press pause. Okay, welcome back. Okay, so for this check-in question then, we've got 20 ostrich heights in the sample. We're going to take an opportunity sample of size 5. So pause the video and do that. And when you're ready, press play. Okay, so as it's an opportunity sample, we must select the first 5 from the sample. Okay, so we're going to be selecting 1.8, 1.9, 2.3, 1.7, and finally 2.1. Part B says, starting from the second data value, take a systematic sample of size 5. So again, what we need to do is work out how many data items we need to be jumping through. So we need, in this case, to select the sampling interval. So we know that there are 20 ostriches, and we need to take a sample size 5. So again, it'll be every 4th person, and we're starting from the second data value. So we're starting with the 1.9. So my sample will be 1.9, and every 4th person, 1, 2, 3, 4, 2.0, 1, 2, 3, 4, 2.6, 1, 2, 3, 4, 2.3, 1, 2, 3, 4, and 2.0. So there's my data values for that sample there. Okay, part C has asked us to calculate the mean height for each sample. So for the first sample here, the opportunity mean, we add them up and divide by 5, get an answer of 1.96. And for the systematic mean, we add up these 5 numbers here and divide them by 5, giving us a mean of 2.16. Okay, and part D, state with reasons which sampling method is more likely to be reliable. Well, again, the systematic sample is more likely to be reliable as it's more random and more representative. The opportunity sample could, for example, just contain the 5 smallest heights. Okay, thank you for listening to today's video.